Look at the space behind your eyes right now. There is nothing there that should be capable of producing agony. No exposed nerve, no open wound, no broken bone. And yet, for 1 in 7 people on this planet, that empty space becomes the epicenter of one of the most disabling experiences the nervous system can produce. You are not sick in the way a fever makes you sick. You are not injured in the way a cut makes you injured. You are witnessing your own brain turn against its own wiring in real time, and there is nothing you can do to stop the process once it begins. This is not a headache. A headache is discomfort. What you are about to understand is a systems failure, a cascading electrical and chemical storm that moves through the brain with the precision of a wave crossing an ocean and the destruction of a wave crossing a shoreline. To understand it, you have to stop thinking of your brain as a single, unified organ and start thinking of it as a densely wired electrical grid, one where a single short circuit in one district can trigger a blackout across the entire city. It begins hours, sometimes a full day, before the pain arrives. This phase is called the prodrome, and most people miss it entirely because it does not announce itself as pain. It announces itself as a mood. A strange, unshakable fatigue settles in, disproportionate to how much you slept. You crave sugar or salt in a way that feels almost involuntary, a signal from deep in the hypothalamus that something in the body's chemical balance has shifted. Your neck stiffens for no obvious reason. You yawn repeatedly, uncontrollably, a behavior linked to dopamine surges in a part of the brain that has nothing to do with tiredness at all. This is your hypothalamus, the brain's environmental control center, sending out the first distress signals of a system about to destabilize. The hypothalamus is not guessing. It is responding to real changes in brain chemistry, changes in serotonin levels, changes in blood flow regulation, changes that researchers can now detect on functional imaging up to 24 hours before a single moment of pain occurs. In other words, the attack has already started. You simply have not felt it yet. For roughly 1 in 3 people who experience migraine, the next phase is the one that reveals just how strange this condition really is. It is called the aura, and it is not a metaphor. It is not a feeling. It is a visible, physical distortion of the sensory world, produced by a wave of electrical silence moving across the surface of the brain. Here is what is actually happening. Under normal conditions, the neurons across your visual cortex fire in an organized, rhythmic pattern, translating raw light data into the coherent image you perceive as reality. During an aura, a wave of intense neuronal activity ignites in one region of the cortex, and then, immediately behind it, the neurons fall completely silent, unable to fire again for several minutes. This phenomenon is called cortical spreading depression, and it moves across the brain's surface at a slow, measurable speed, roughly 3 to 5 millimeters per minute, a literal wave of electrical shutdown rippling outward like a stone dropped in water. As this wave crosses the visual cortex, it does not simply dim your vision, it corrupts it. Zigzagging lines of light appear at the edge of your visual field, shimmering and expanding, a phenomenon called a fortification spectrum, so named because early physicians thought it resembled the walls of a castle under siege. Blind spots emerge and grow, swallowing parts of the world in front of you. Some people report entire objects appearing to shrink or distort in size, a symptom so specific it has its own name in medical literature, borrowed from a work of fiction because no clinical term captured it as precisely. Understand what this means. Your eyes are functioning perfectly. The light entering them is unchanged. The distortion is happening entirely inside the processing architecture of your own brain. Reality has not changed. Your interpretation of reality has been hijacked by a wave of electrical silence you cannot see, cannot stop, and cannot outrun, because it is not happening to you. It is happening inside the very mechanism you use to perceive anything at all. And this wave does not stay contained to vision. As cortical spreading depression moves across the brain, it begins to cross into territory connected to one of the most sensitive nerve structures in the entire human body. The trigeminal nerve, the largest and most complex of the cranial nerves, responsible for nearly all sensation in the face, the scalp, and critically, the blood vessels lining the meninges, the protective membranes wrapped around your brain. This is the moment the true mechanism of migraine pain begins. As the electrical wave passes near the trigeminal nerve's territory, it triggers something the nervous system was never designed to produce in this way, a release of inflammatory signaling molecules directly onto the blood vessels of the brain's protective lining. The nerve, believing it has detected damage, begins broadcasting distress signals into a region of tissue where no actual injury exists. It is a false alarm, but the body cannot tell the difference between a false alarm and a real one. It responds exactly as if the brain were under physical attack, because, as far as the trigeminal nerve is concerned, it is. This is the hinge point of the entire experience. Everything before this moment was electrical, was invisible, was silent to everyone except the person experiencing it. What comes next is chemical, vascular, and it is about to become impossible to ignore. The molecule at the center of this next phase has a name that, once you learn it, you will never forget, because it is the single most important discovery in modern migraine science. It is called calcitonin gene-related peptide, or CGRP, and it is released in massive quantities from the endings of the trigeminal nerve the moment that false alarm begins. CGRP is not a bystander in this process. It is the primary driver of the pain you are about to feel, a molecule so central to the migraine mechanism that an entire generation of modern medications exists for the sole purpose of blocking it. Here is what CGRP actually does inside your skull. It binds to receptors on the smooth muscle lining the meningeal blood vessels, and it forces them to dilate, to swell open far beyond their normal resting diameter. At the same time, it triggers what researchers call neurogenic inflammation, a localized immune-like response that causes these same blood vessels to become inflamed, sensitized, and swollen with fluid. This is critical to understand. Your blood vessels are not simply widening, they are becoming inflamed, in the same physiological sense that a sprained ankle becomes inflamed. Except this inflammation is occurring directly against the most pain-sensitive membrane in the human body. Now the blood itself becomes the instrument of torture. With every single heartbeat, a fresh pulse of blood surges through these dilated, inflamed vessels, stretching them further with each contraction of your heart. And here is the mechanism that explains the single most recognizable symptom of migraine: the throbbing. That rhythmic pounding sensation you feel is not a metaphor for pain. It is the literal sensation of your own pulse dragging across nerve endings that have become hypersensitive to the slightest mechanical stretch.
Your heartbeat, an event you never notice under normal circumstances, has become a weapon aimed directly at your own trigeminal nerve once every single second, for hours at a time. This is the process called peripheral sensitization, and it explains why simple movement becomes unbearable during an attack. Nerve endings that once required significant force to activate now fire in response to the faintest pressure change, the faintest pulse of blood, the faintest shift in posture. Bending over to pick something up, an action that moves cerebrospinal fluid and shifts intracranial pressure by a negligible amount under normal circumstances, becomes an act of controlled agony because the trigeminal nerve endings lining your meninges have been chemically rewired to interpret negligible pressure as catastrophic threat. But the nervous system does not stop at peripheral sensitization. Given enough time, typically somewhere between 20 and 40 minutes into sustained trigeminal activation, the pain signal begins to travel backward, up the trigeminal pathway into the brainstem itself, into a relay station called the trigeminal nucleus caudalis. And once this relay station becomes sensitized, something far more insidious happens. It is called central sensitization, and it means the pain response is no longer confined to the blood vessels where it started. The threshold for triggering pain drops throughout the entire central nervous system. This is the biological explanation for one of migraine's cruelest symptoms, allodynia, a state in which completely harmless stimuli become sources of genuine pain. The weight of eyeglasses resting on the bridge of your nose, a ponytail pulling gently on your scalp, the texture of a pillowcase against your cheek. None of these should register as painful under any normal circumstance. But once central sensitization sets in, the brainstem has effectively turned up the gain on every incoming sensory signal, and stimuli that were previously invisible to your awareness are now processed as active threats. This same mechanism explains photophobia and phonophobia, the extreme sensitivity to light and sound that defines a full migraine attack. Recent neuroimaging research has identified a direct anatomical pathway connecting light-sensitive cells in the retina, specifically a class of cells called intrinsically photosensitive retinal ganglion cells, directly into the same thalamic relay stations that process trigeminal pain signals. In simple terms, your brain has a wiring error, or more accurately, a wiring overlap during a migraine attack, one where visual information and pain information become tangled together in the thalamus. Light is not simply uncomfortable. It is being processed, at a neurological level, as an extension of the pain itself. This is why sufferers instinctively retreat into darkness. They are not being dramatic. They are removing a direct source of additional pain input from a thalamus that can no longer distinguish between light and injury. Sound follows a nearly identical pathway, with auditory processing regions showing similarly amplified connectivity to pain centers during an active attack. Even smell becomes a liability for many sufferers, with common odors like perfume or cooking food triggering waves of nausea, itself driven by the vagus nerve's proximity to these same overloaded brainstem structures. The entire sensory architecture of the human body, vision, hearing, smell, touch, has been recruited, against your will, into a single unified experience of suffering, orchestrated by a brainstem that has lost its ability to filter what matters from what does not. And the vascular storm continues throughout. Blood vessel walls stretched thin with every pulse, chemically inflamed by CGRP, mechanically irritated by movement, feeding pain signals upward into a thalamus and cortex that are now interpreting nearly every form of sensory input as an escalating threat. This is not one symptom. This is an entire nervous system, from the meninges to the retina to the inner ear, locked into a single, self-reinforcing loop of amplified suffering. And it can remain locked in this state for 4 hours or for 72, somewhere between the 2nd and the 7th hour. For those fortunate enough to have a shorter attack, the system begins, slowly, to run out of fuel. CGRP is not released infinitely. The trigeminal nerve endings that flooded the meningeal vessels with inflammatory peptides begin to deplete their reserves, and without a constant supply of new CGRP, receptor activation on the blood vessels starts to decline. The vessels, no longer forced open by continuous chemical pressure, begin a slow, uneven return toward their normal diameter. But resolution is not instantaneous, and it is rarely gentle. As inflamed tissue begins to calm, the immune-like response triggered by neurogenic inflammation must also stand down, a process that involves the gradual clearance of inflammatory byproducts from the extracellular space surrounding the meningeal blood vessels. This clearance process itself can take hours, which explains why the transition out of a migraine attack rarely feels like a switch flipping off. It feels like a tide receding, slow, uneven, leaving behind a landscape that is calmer, but far from undisturbed. This is the postdrome phase, sometimes called, with grim accuracy by patients themselves, the migraine hangover. And the comparison is not simply poetic. It is neurologically apt. Functional imaging studies conducted during postdrome show altered blood flow patterns persisting in the same regions of the brain that were active during the pain phase itself, evidence that the neurological aftermath of an attack lingers long after the throbbing has stopped. Cognitive fog sets in, a measurable decline in reaction time and working memory that can persist for a full 24 hours. Fatigue settles in with a weight that sleep does not immediately resolve. Some describe a lingering scalp tenderness, the last residue of peripheral sensitization slowly unwinding itself, nerve by nerve. Mood changes are common during this phase as well, and they are not incidental. The same hypothalamic and serotonergic systems that initiated the prodrome hours or days earlier are now recalibrating, and this recalibration process can produce a temporary state of low mood disproportionate to any external circumstance, a direct neurochemical echo of the systems that triggered the entire event in the first place. In a strange, almost poetic symmetry, the brain that gave the first warning signs of the coming storm is the same brain now issuing the final signals of its slow return to baseline. Consider for a moment the sheer scale of coordination required for this event to occur even once. A wave of electrical silence moving across the cortex at a measurable physical speed. A cascade of neuropeptide release, triggered by a nerve responding to a threat that was never real. Blood vessels forced into inflamed dilation by direct chemical signaling. A brainstem relay station lowering its threshold for pain until harmless stimuli become intolerable. Retinal cells rerouting light information directly into pain processing centers. An entire sensory nervous system recruited and weaponized against its owner for hours, sometimes days, before finally, gradually standing down. This is happening inside human skulls, right now, at this exact moment, to roughly 1 billion people worldwide who live with migraine. For some, this entire 15-stage cascade unfolds once a year. For others, it unfolds multiple times per week, an entire neurological siege repeating itself with brutal, exhausting regularity. Each episode, a full-scale mobilization of the nervous system against a threat that exists only within its own miscalibrated wiring. And here is the detail that makes this condition genuinely remarkable from a scientific standpoint. For the majority of human history, this entire process was invisible. No scan, no blood test, no external mark on the body could prove that any of this had happened. Sufferers were told, for centuries, that the pain was psychological, that it was exaggeration, that it was weakness. It took the development of functional neuroimaging, the identification of CGRP as a specific molecular target, and the mapping of cortical spreading depression as a measurable electrical phenomenon, to finally prove what patients had been reporting all along. The storm was real. It was never in their head, in the dismissive sense of that phrase. It was, quite literally and quite precisely, in their head, in the most complex 1,500 grams of tissue in the known universe, executing a cascade of electrical and chemical events so intricate that science only fully began mapping its mechanism within the last 3 decades. The next time this wave begins somewhere behind your eyes, or the eyes of someone you know, understand exactly what is unfolding. Not a headache, not an exaggeration. A precise, traceable, biologically real neurological event, moving through the brain the way weather moves through a landscape, following laws as measurable and as real as anything else in physics, chemistry, or biology.